Hello viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're gonna talk about Hyperloop test. So let's dive right into it. Well, first thing we have to understand what the heck we are talking about. We are talking about a test. Now, this happened on 8 November 2020, so it's quite recent, and it was done by the corporation Virgin Hyperloop. Now, be mindful, Hyperloop is an open name. There are many companies that have Hyperloop quote-unquote technology, but this is what we are talking about, Virgin system. Now, this was done in Las Vegas, Nevada, USA, obviously, and in what we call DevLoop. Basically, it's a test track of 500 meter in length. Now, it's a full size one. That is the interesting part. There are many test tracks, but those are not full size. This is a full size system, and the pod they built, pod is Gen 2, because they already had a pod, but that was Gen 1. That was more of a like figuring things out. This is a kind of like a more closer to a mock-up of how actual pod will look like. So this is XP-2. Now, two people carried out this test, and they were going at 170 kilometers per hour. Now, so first thing comes to your mind is like, dude, that's slow. The reason is the length is very small. So fundamentally, can they achieve faster than this? Absolutely. Their pods have already achieving like 200 plus or even 300. The problem was the G-force would be too high, and something odd happened. I've looked into the video. It's like for some reason it's vibrating too much. That does not make sense given the fact it does not have a wheel that is inducing vibration or like some kind of motor, and it's traveling through a vacuum tube. So fundamentally, why the heck it's vibrating so much? That was weird to me, but like again, maybe they should work out the kinks, and I'm hopeful they will, because again, Japanese bullet train was so stable that like they put a pen on like this and it will remain stable. I'm damn sure you could not do this within this puppy. So I think they still have a lot of work, bugs to work out. So that speed kind of makes sense. But this was more of a like a demonstration. No, this system is a human safe system. So what about the tube pressure? That's the core aspect of it. Like how low? Like many people use, oh, it's low pressure. No, it's as close to vacuum as tangibly can be achieved. So they went it down to 100 Pascal. Now, to understand this much more efficiently, think of it this way: 0.01 psi. So it's not even one whole psi. It's not even 0.1 psi. It's 0.01. So fundamentally almost vacuum. It's like why they are not going below. It will take months to pump it down this much. So this is the test that was done successfully. Now, I keep calling this puppy a scam, and most people don't understand what the heck I'm trying to convey. So I want to make this very clear. If you watch my video that was done 2 years ago, I specified at the end of that video is that this can be built. It will be just costing you too much money. Now you might be like, hey, we humans, we have done expensive things, but most of the time expensive things are done either in fear or some sort of glory kind of project. Commercial, private, public partnership projects cannot have that kind of luxury. For example, if you're building a dam, it has to cost within certain amount of budget. Again, you can go a little bit over budget, little bit here and there, but you can't go bonkers because the project will be abandoned. This is not a like glory project where Apollo mission is done, like we're gonna do this no matter how much, but that's not gonna be happening here. So fundamentally, you have to look at much more absolutely, and it's not a private system. Your money is at stake here, so it is something very serious, and we have to look at it very, very carefully. So the reason why I keep calling it scam, because the first thing Elon Musk said, it would be cheaper than air travel. Or sometimes I like some people quote like, cheaper than bus travel. I'm like, no, that's not happening. That only way that can even come remotely close to be possible, it would be like if government is just subsidizing 100% of it. At that point in time, it might as well be possible, but without that, that's not possible. For example, one very high-speed railway network that is successful, time-tested, and actually serves its people, Shinkansen network from Japan, bullet train. Its ticket is so expensive, you literally can buy a flight. Is the sole reason is it's much more convenient, so people use that, because airport have like notorious check-in and check-out time. People are like, just go with the train, it's much more convenient. So you can understand that aspect. Like all high-speed trains are expensive, and somehow you're gonna make that is much faster than those things. Heck, even achieve faster than aircraft speed, and somehow it's gonna be cheaper. No, just no, that's just a nope. And then you have to understand this, how a public government or things of that nature, government entities select a project is directly dependent on how long you're asking. Basically, if you're gonna go to a company, it's like, bro, we're gonna build this metro system for you, and it's gonna take 10 years. They will like, we may not be in office, but 10 years is enough that people might remember us. So they were like, okay, we may look into this. If you say, hey, we're gonna build this in 4 years, they're like, whoa, I will be in office when this this project started and this finished, and I'll be in public's mind. So they're like, okay, they will sign up even more expensive projects. So timeline is very critical, and timeline is sold by the private manufacturers, whoever gonna manufacture these things, or contractors, things of that nature. So they were claiming this is few years away in 2016. 4 years have passed, and at this point in time, the biggest achievement, now be mindful the world ended in 2020, so I think you have to give a clock reset, but still if the biggest achievement at this point in time is like a tube with 170 km/h speed, which you could have easily achieved in a normal air system, basically anything, even a car can go that fast. It's like, really? So that's the whole point. And this is a public sector project. Basically, it's like a flyover, it's like a railway network, so it's your tax. And why it's important, think of this way. Let's say Indian government is wasting $10 billion in this puppy, so that $10 billion is taken away from central government, and that money is burnt. Now what will happen, side effect of that? Well, we won't get a high-speed railway network, which could be built at this point in time. We know how to build high-speed railway network. Now it may get delayed, but at that point in time, you will know who's to blame. At that point, it's like, dude, the contractor is trolling, or the, like, some land issues or things of that nature. You know what is the problem and you can solve it. But when you're talking about something that is unknown, what the heck you're gonna do? And once the money is burnt, at that point in time, you're like, okay, that amount of money is burnt. The government does not have infinite money, so they cannot just like, okay, magically we'll start again. That money is lost. You do not have anything to use by, and it has happened. Like, there are many interesting flyovers that goes to nowhere because those projects were abandoned because it took too much money. So fundamentally, that is a very horrifying aspect, and it will be safest mode of travel. Now, any person says that on Hyperloop fundamentally means they have zero concept of what we call mathematics. You cannot call something like, safest if it does not even come close to the same numbers. For example, a train is moving. In case of India's railway network, at its peak capacity, it's traveling, like its carrying capacity is more or less 100% of Australia's population is on the rail. 100%. That's how big Indian rail network is. That's how many people are using it. And then you will be like, okay, people die. Like, yeah, absolutely, a lot of people die, but number is huge. So when you go into percentage sector, it's barely 1 or 2%. Now same goes to aeroplanes. Do people die? Absolutely. But how many people travel? Then it will be like, 0.000. That's why air travel has that reputation. It is the safest mathematically proven system because it has moved hundreds and thousands of people hundreds of times a day. So at that point in time, you can claim this. Compared to a system that nobody has tested, nobody has used, from like going from point A to point B, actual journey wise, hundreds of people, or hundreds of transition one point or another, and you are claiming it is to be safest. By that logic, Wright Brothers first plane should be the safest system out there, because they first time we tried it, nothing bad happened. It's like, dude, space shuttle was also like that. It did actual mission, but it was the deadliest spacecraft ever built by humans. So that is why I keep classifying a scam. The cost would be too damn high, and by the time governments would have done burning the money away, then they will realize it. And my country is one of them. So what about the safety? This is one of the aspects that I criticized in my second video I made about this. Is basically, again, same thing. You cannot call safety based on like, okay, one test. No, you have to do hundreds of it, or something comparable to the project that you are replacing. So if you are replacing a metro project, and metro project is supposed to carry, let's say, 75,000 people an hour, you have to do something equivalent to that. Then you can care, oh no, mine system is safer. You cannot be like, oh, I'm only carrying 100 people, but nobody has got injured. I'm like, so that's the whole point. That was like, damn, like seriously, nobody knows mathematics. Nobody. I'm like, I'm not that good at maths. And one thing you have to understand, safety is a very simple thing. We can achieve safety, absolute safety also, but it costs a lot of money. For example, these are the data points that Virgin system is providing. For example, how the heck they're gonna handle, let's say the tube gets stuck, the pod gets stuck for some reason, emergency brake or something like that. Let's something happens and the passenger has to get out. They cannot do get out, because if the moment they open the door, it's like, vacuum, they're gonna suffocate. So how the heck they're gonna handle that? They have rapid tube repressurization system. So basically the tubes have valves in there, and the reason why they have lots of valves is simply because they want to gently pressurize the system, rather than like, they don't want to do that, because that will create a physical shock wave which could harm or flat out destroy things. So they have to do it gently, but their mathematical assumption is, at this point in time, again, I'm hopeful that they have done the actual testing. It can be done much quicker than a plane. That's their data point, is like plane can go from unbreathable altitude to breathable altitude. So the idea is, the moment an emergency is detected, an emergency valve could be opened and it will flood the system so person can breathe inside. That's their step one, and that makes everything else simple, because that vacuum is the biggest issue. Then you have how the heck a cabin is going to remain pressurized. It has air canisters. It's almost like a space shuttle, because again, aeroplanes get their air not from basically air canister. They get the air from engines. Engine is like, sucking from, there is a bypass duct that is putting air into the chamber, and then you are talking about something that is working in a vacuum. There is nothing to suck in, so they're fundamentally relying on air canisters. And even in aeroplane industry, the oxygen masks that you see, they are running on a chemical process, not on an actual like air canisters. And then fire is a very critical aspect that you have to understand, because when you are in a vacuum, it would be much worse than the worst case scenario. Fire is happens in what we call submarines. This puppy is 10 times worse, simply because when the submarine catches on fire, there is no place to go, but at least the heat can be convected away because it's surrounded by water. It's surrounded, like in case of pod, it's surrounded by vacuum, which is absolutely perfect insulator. So fundamentally only infrared radiation will go away. So it's the same amount of fuel that will in a normal scenario burns inside the pod, that will heat the pod to, let's say, 200 degrees Celsius, will heat the pod to 600 degrees Celsius, simply because the heat is not going anywhere, it's not conducting anywhere away. So they have automated fire suppression system. It is very critical. The fire cannot spread, because the moment that happens, they will be cooked inside instantaneously because of the vacuum aspect. So that's one thing. And they have air scrubbing, because this is a more close to a basically spaceship rather than like an aeroplane. So they have to remove carbon dioxide. Just because you are flooding the system with oxygen, it does not work that way. 13% carbon dioxide equals you dead. So you want to be scrubbing the carbon dioxide out. And then they have emergency egress. This was the most critical aspect that I criticized the most. And if you are familiar with basically tunnels that go under the sea or things of that nature, they generally will have two train tunnels that are going one up, one down, and they will have a tunnel in between. That part most people don't think about, but that's a very serious expenditure, and it helps in multiple ways. For example, primary help would be maintenance. So they can do maintenance wherever they want to do it, and in case of emergency, they can evacuate to a central system. Now in vacuum system, you cannot evacuate. So they are first thing they're gonna do, anything goes wrong, the first thing will be they will do is remove the vacuum. And then they have emergency egress points at every 70 meter. This is a 500 meter track, and they have to do this at every 70 meter. So good luck trying to figure out how much it's going to cost if you want to do it for 100 kilometers. And they have airlocks. Again, airlock is not that expensive, especially if you have emergency egress system. So this is the safety points, and you can understand this if you thoroughly study these things. It's not impossible, it's just good luck trying to make them in a budget. Now another aspect is, let's say you somehow magically solved all that. Let's say some modern technology happened, some modern composite happened, or just economy of scale happened. Let's say you figured all that part. The final nail in the coffin would be, I'm not talking about land cost, that will destroy this project before it gets started, but low capacity is the final nail in coffin, simply because it's a public project. It has to carry quote unquote public means large volume of people. You cannot carry large volume of people in this system no matter what you do. Even with ludicrously high speed, you have to give very significant amount of gap, and you have to give more gap compared to a metro system, compared to a rail system, simply because of the high speed. Because you do not, like, again, even if you magically built a magical brake system that stops the carriage going whoosh, you stop it like that, here's the person inside will become into what we call chunky sauce. You don't want to do that. So fundamentally you have to have a pod gap that is bare minimum, like safely deceleration limit, and then you're not going to be like absolutely running like that. You will be like, okay, if this is the safely running road, let's say 15 kilometers apart, and then you're gonna put like 30 kilometers at bare minimum, because again, you could have detection error where like, okay, the pod did not clear the second signal, but like, you thought it's working, and then you have to do that. And many accidents have happened with this sort of issue. That's why like the gap is always much more than that. That's why like we learned this the hard way. So you have to do this, and the pods cannot carry too many people. Like their design is 20 to 40 people. That's not a lot of people. Not a lot of people. Like for example, you look at an airport, there are like a lot of photographs that people are actually doing 1 hour photograph or 2 hour photograph, and they're just stacking all the aircrafts. Then you will get the sense of it, like how many people use a modern basically airport, especially a busy one. You will be like blown away. And like this is a basically London airport, I'm saying railway station. Not exactly sure, but UK one, I'm pretty sure. I'm not even gonna try to scare the hell out of you if I showed you an Indian railway station. So you have to understand, the sole reason these expensive things are even feasible is simply because so many people are using it. Per head cost is low. If you do something like this, like Hyperloop, per head cost fundamentally cannot be low. It has to be high, because again, you are trying to recover that kind of capital cost from few amount of people. You have to keep the cost high. But again, you build this system not as a luxury system for ultra rich. You took the money from normal tax people. So you can understand, that's the whole thing. That's why it cannot be done on cheap price. Like the per head per hour gap is too damn low. Like you compare to a metro system that could be as high as like 70,000 people. In some large systems you will be like 700, best case scenario. So that's the whole thing. Now timeline, this is the one thing that you have to understand absolutely very thoroughly. One thing money cannot buy. Let's say you are so rich that you're like, let's say Dubai, you're like, dude, I'm gonna buy a toilet pan that is made out of gold. Fundamentally speaking, that some people have actually done that. So again, you could be in a scenario where it's like money is no object. Like fundamentally you can be in that position, but one thing you cannot buy, it's time. So if somebody claims like, okay, we're gonna build this road and we're gonna block this area, we're gonna do some construction and that should be done in 4 years, okay, everything awesome. You are losing the revenue because of that downtime, but let's say you are planned for 4 years and it dragged out to 5 years in, let's say, flyover case or things of that nature. You're like, okay, you can do that. But if you're talking about something that could drag out for multiple times, like multiple deadlines it could skip, there is a very serious risk it would be just abandoned project. It would be like, oh, we wanted to build that wind and we just abandoned it. It costed too much. It has happened with multiple times with multiple things. And simple things, like when you are trying to, this is not like what we call James Webb telescope, so people will keep dumping money. It's not like that. So there is a very serious risk that people will start building it and then the project will be cancelled. And people will like, dude, you took the money from the central government, you took the money from our tax system and you did not give us anything. You're just like, lol. So that's the whole thing. That's why timeline is the most important thing. It's like, if the company cannot even build a demo system in the timeline they are claiming, how the heck, like every Tom Dick and is like, by 2018 this will be everywhere, by this Dubai system will 2019 launch date. And I'm like, really? Like, so far all we have is a test track with some people inside it on a very slow speed. That's the whole point, because missed deadline always makes the project expensive, and it's compounding interest kind of scenario. It's like, okay, I block this road, this kind of revenue loss I'm happening because of this road blockage, and every year it will keep compounding. So at some point it reaches a point where it's like to abandon project. So fundamentally timeline is also critical. Like, again, it's not like SpaceX, oh, we're gonna, like in 2016 they claim we're gonna land on Mars by 2018 or 2019. Again, that does not happen. Nobody's hurt or injured or lost. It will happen if something like this happens. So what we can expect in the future? Well, this is literally turning out to be another space shuttle, because again, people who built space shuttle, they knew for a fact it was not a good system. And again, politics, hoo-ha, ICBM research, solid boosters, all that jazz, it did not work out. And again, you can check it, like they tested it, it actually works. But again, the deadliest spacecraft we ever built. So things of like this nature does happen. We are human, we are fallible, so this happens, and you have to understand it. There are enough dumb people, or enough people who can be agitated very easily, that they will be willingly burn money away. Oh, India wants to have some super, advanced technology, let's burn money away. It's very easy to convince people into doing that. And for example, there are some small scale example. Solar roadway, this couple freaking tricked the whole goddamn planet, tricked the energy department of USA to give them billions of dollars. I'm not talking about million, billions of dollars, and they're just like, lol. And after that, here's the interesting part. After that, after years of trolling, after, like, I'm pretty sure I saw this when I was a student, so you're talking about years of ago, French government is like, let's try to build this again in our system. Oh, we went bankrupt because of this. And I got a heart attack inducing news that apparently Indian government in Mumbai was trying to do this. I did not look any further into that, because like, there is certain level of stress I can manage, and this is too further for that. So you have to understand that it has happened enough times in humanity where I'm like, yep, no matter how many engineers keep yelling, dude, don't do this, they will do it. And after the loss of money, it's like, that's why nobody takes science seriously. Dude, you ignored the science, that's why you are stuck in that position. So solar roadway was like that, Theranos was like that, space shuttle was like that. So fundamentally, I'm very saddened by the fact that the amount of money and the amount of press that horrifies me. It's like, press, people thinks it's true. It's like, nobody's thinking in this way. Like, dude, you cannot claim it safe if only one person have used it. You cannot claim it safe unless you compare it to something equivalent, or something that is trying to replace. If it's trying to replace something that carries thousands and thousands of people, try to go to Delhi Metro, or heck, Australia's Metro. Try to do that. I have one friend living there, that's how I know. So fundamentally, the amount of people is moving from point A to point B, and you're gonna tell them, oh, we're gonna replace it with this system that's gonna carry 24 people. Good luck, bro. Good luck. So future is not bright in this kind of scenario. I'm like, there's a very serious chance we may be burning like 80 or 90 billion dollars of money by the time it's done. So this was my horrifying presentation of Hyperloop. I hope you liked it, learned from it. In that case, please click the like button, share it with your friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.